A regular polygon is a polygon with congruent sides and angle. So a polygon is regular if they have in geometry, congruent means equal. So in a polygon, if you notice that the sides, so I'm using this as the side, double hashes. So if all the sides are the same, so if here is 2 cm, the other side will be 2 cm. And also the interior angles must be the same. So if here is theta, 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 here is theta. So also if here is beta, here is beta, here is beta, here is beta, and here is beta. So they must have equal angles and sides. And there is one, we need to get formulas here. We need to get each of the interior. Since they are equal, we can note each of them since they are equal. So what are we trying to say? Since the sum, so we are talking about the interior angle. Since the sum of interior angles, we are getting three formulas here. Of a polygon is n minus 2 times 1/8. And since they are equal, to get each of them, I divide by the number of sides. Yes. As example, now if you have 5 oranges and you have 5 people to share, each of them will now get 5/5, which is 1 orange. So each interior angle of a regular polygon, we're talking about a regular polygon, is now the total, which is n minus 2 times 1/8 over n. Yes. And also, since the sum of each of the exterior angles is 360 degrees, each exterior angle is now 360 over n. So that's another formula. So we have how many formulas now? We have 2. This one, but we're going to use, most questions will come this way, and this. And also, finally, we have the exterior angle. Sorry, the central angle is always equal to another thing, that the central angle is always equal to exterior angle. Yes. So for any regular polygon, the central angle, maybe if you have a center, the central angle, that's the angle formed at the center, will be the same as the exterior angle. So that's the three formula. Each of the interior angle is n minus 2 times 180 over n, and each of the exterior is 360 over n. Finally, the central angle equals the exterior angle. So let's look at this question. They said, if 3 regular polygons are arranged as shown, then A is dash. Okay. We have, as you can see, they said 3 regular polygons. So, how many sides? N is 5. 1, 2, 3, 4, 5. So to calculate, because we are looking for this angle, once we know the remaining, we use angle at a point. Remember, angle at a point is 360. So once we're able to get others, we are done. So how do you get each of these? Let's call it x, or maybe let's call it theta. Let's call it theta. So you see that theta, which is each interior angle of a regular polygon, is now n minus 2. 180 over n. So in this case, we have 5 sides over 5. So we have 3 times 180 over 5. So which is 3 times 5 in 18 is 3. remaining 36, so we have 36 degrees. So 36 times that is 108. So each of them is 108. Therefore, if we sum angle at a point is 360, meaning each of them theta. So we have 108 plus 108 plus 108 plus A is equal to 360. Yes. And 108 plus 108 plus 108 is, that's times 3. 3 times 8, 4. And then that 230. So 324 plus A equal to 360. So we have A is now 360 minus 324. So I have the answer is 36. So that's it. A degree is 36. So A is 36. Our answer is option A. So it's a very technical, question. The next one, they said A, B, C, D, E, F is a regular polygon. We're asked to find angle AGF. So if you are looking for angle, this angle is meant for the middle letter, AGF. So we're looking for the middle angle. So where is A, where is G, where is F? So we're looking for this. So let's call it theta. And how do you solve this? It's simple. We are given that A, B, C, D, E, F is a regular polygon. So all the sides are equal. All the sides are equal. And if we know that all the sides, what's the name of this polygon? This is a six-sided polygon, hexagon. So each interior angle is 6 minus 2 times 180 over 6, because n here is 6. We have 6 sides. So we have, this is 4 times that. This should be 120 degrees. That's 4, and that's 120. And since this angle, that's this, is 120, this is also 120. This is 120. If you notice, you see that here is A, B, and F. This is 120. And we have these sides equal. So what's the name of this triangle? We have an isosceles triangle. And you know, an isosceles triangle, even if you don't know, an isosceles triangle means two sides are equal or congruent. If you don't call it equal, you call it congruent. So that's it. And since they are congruent, these two angles opposite the sides will also be equal. So since I have 120 here, each of these will be 30. Since the total angle, the sum of angle in a triangle is 180. Since one is 120, the remaining are the same, meaning that each will be 30. So I'm saying that this angle here, this is 30. This is also 30. That same logic here is also 30. Here is also 30. So what do you have to hear? What do you have to say? Look at this triangle. Look at this triangle B. Look at this. Look at triangle A, B, and G here. I've gotten here to be 30. I've gotten here to be 30, yes. Using the same logic. Here is 30, 30. This is 120. The total here is 120. So here is 30. Here should be 30. So this is 90. Why here is 30? Do you understand? I'm saying this interior, each of them is 120. And since I have gotten that these ones are 30, so this is 90. So looking at this, remember we are looking for this angle, theta, which is simple. Theta will be equal to 30 plus 30, which is 60. Yeah, we call it exterior angle theorem. Even if you don't know it, we can still get it from here. Since here is 30, here is 30, here is 120, making here to be 60, angle on a straight line. So if here is 120, here is what? 60. Or you use the exterior angle. If you add it in any triangle, if you add the remote interior angles, so if you had, maybe if here is A, if you add B, you get C. So C is A plus B. Or if you have here E, maybe here is F. If you add B and F, you get E. Or if you have G here, if you add A and F, as this and this, you get it. So this is called exterior angle theorem. So it's very easy to solve. That's our answer. Our answer is option B.